Hi everyone. Today I wanted to talk about a concept in Godot called custom resources. I feel like they're actually chronically underused and far better for a lot of different pieces of functionality that you might implement than a lot of people realize. You can see custom resources in things like curves, animations. There's just a bunch of places where they actually show up in the engine where you might not think they did. And I've gone to a little bit of effort here to create a game just to demo this, although it is actually kind of a fun game. And I'm going to show you how to create and use these custom resources and why you might want to instead of a scene, for example. One thing I forgot to mention at this point, and I'm splicing this in after the fact, obviously, is how to make your first custom resource. How do you make the base custom resource like I have with this? The easiest way to do that is go to whatever your folder is, right click it, new script. Come to inherits, and here, instead of your class name, you just type resource. Then you go ahead and put in your script name here, whatever you want to call the base resource. And it doesn't have to be a base resource. You don't have to have things extended if you don't need to. But you put that in there and hit create, and that'll create it for you. Okay, back to your regularly scheduled programming. As you can see here, I've got this resource. I'm calling it target res is the name. The name of the file is target resource.gd. And it's in my targets folder here, target resource.gd. And you put the class name on it so you can actually create an instance of it later. But one of the nice things about this is when you're creating a new actual instance of it, you can simply right click, go to new resource, type in target res in this case, and notice it brings up all the derived types. Now, it supports polymorphism and inheritance, just like any other class in Godot. And I think that's really nice. In this case, as you can see, my base here, it has an empty get targets function, so that's not going to return anything at this point. It doesn't even return at all. It just passes. And it's got get closest enemy. This is just a piece of functionality that I noticed that all my derived types actually, or a large majority of my derived types, actually use. And I thought it made sense to put this in the base class because it often makes sense to put logic, not so much data, in the parent of the child so that the different children can use that logic in the future. And speaking of that, I really wish parents these days had logic that their children could use instead of the crap that we're seeing. But in any case, the nice thing about resources too is they're shared. In addition to supporting polymorphism, if you have the same resource loaded and you load it by two different nodes in the same scene, they'll actually share the exact same data and it'll be a very nice little thing. You can do a duplicate to deep copy them, but if you want them to share the same data, then a resource is a perfectly fine way of doing that. Resources are good for pure logic because they don't need access to the scene tree. So if you're worried about polluting your scene tree with a bunch of scenes that don't look like they're actually necessary, you just want a script to run logic, consider using a resource instead. And generally speaking, scenes are much better for things that need to directly manipulate the scene tree itself, which sounds a little redundant, but basically you wouldn't want to use a custom resource if you have to do a bunch of adding and removing nodes and stuff like that to the scene tree. You wouldn't want to do it if you need to reference animations or things along those lines. This is my experience, but I think it's pretty valid. Basically, when you reference animations and things, I do it via string or some sort of enumeration or something along those lines. Something that gives me a little more flexibility than referencing the resource for these things directly. And one final super nice thing about resources is you can actually make them tools. I'm not going to do it for this because I don't need to edit anything directly, but this means that if you change a value in your resource when you're actively editing it here in the editor, you can make a change in the values for the resource itself. So for example, if I go new resource, and I pick a chain target resource, and I say this chain attack resource, I think. Now it doesn't have any other logic other than target name, so having tool here wouldn't be useful at all. But if I did have something like, for example, a curve or some other thing that might ultimately be something that I can edit directly in the editor, then having tool up here would update that thing in the user interface here when I change it over here. And that is just super nice. I think that's just a really cool little tip that a lot of people don't realize with scripts, and especially with resources in Godot. And then finally, another really nice thing about a resource over a scene is they're a lot easier to replace. And this is because they don't need access to the scene tree. If I have a character and I've built two different types of AI for it, both using a base resource, and then one's an aggressive AI. It says when there are targets in the area, attack them. The other one's let's call it a sheepish AI, that when there are targets in the area, run. At runtime, instead of having to delete a node from the scene tree or somehow or other disable it, and then enable the other one or add a new node to the scene tree for the other AI, I can just literally take my instance here, load that, and swap it out at runtime, and it'll just pick up the new one and it'll just run it. I don't have to do anything with the scene tree at all, which is, in my mind, incredible. You really want to be delegating logic here. That's why it's not as useful when you do it with stuff in the scene tree, because that's primarily visual, and if you're not delegating, then it's better just to have stuff in the static scene tree so you can literally see it and reason about what's happening. And then finally, the other nice thing about this is the fact that you get inheritability and polymorphism. So let me actually just jump in and show you how this works. I have a game here where it's sort of an infinite runner, and enemies show up on the screen. I just have one type of enemy now. It's a sort of like a bat, bee of some kind. It's just some little enemy that I made. And all enemies will have a group of enemy. Some will have groups of ranged or melee or any sort of different thing that you might have, flying, stationary. You can use the groups however you want. This is just how I have my game set up. You can do this in really any logical way. In fact, this doesn't really care about the fact that they're in groups, except for the fact that I have a derived version called a group target. And notice this just exports the target group name. So what that means is it goes through the list of enemies that exist in the scene, passed in from there, and it checks the ones that are in that group. If they're in the group, it pushes it back and returns the result. That's great, but to show you why inheritance and polymorphism is so useful here, let me actually just do a demo. So if I actually create a group target, let me do this. Ranged attack. Actually, let me do ranged target resource. And you hit save. Now that is, come down here. You can see it's a TRES file. So this is like almost like a compiled instance of that resource that sits on my hard drive. We can give the target name. This is mostly just for the user interface. I actually haven't even implemented it yet, but I'm going to put it in anyway. We'll say ranged targets. The idea is that'll pop up when you select an attack that uses this type of target. We're going to say the target group is just ranged. Then I'm going to let's pick, I don't have any other enemies, so I'm going to make an instance of, let's do the closest enemy target. So we go here, we pick this one, closest enemy target res. That's the parent in this case. This is sort of like the definition of the class that gets instantiated and turned into a text res file. That's what that stands for, tres. So we'll just say closest target resource. And we'll just say closest enemy. And this is all just a setup, because if I wanted to apply multiples of these at once, let's say I wanted to make it a chain attack and only hit ranged ones, if I only had one custom resource, this target resource base, I would have to have all the logic for every possible combination of these here in this. And you can imagine just how painful that would be. I would have either switches or if-elses or I guess match and Godot, not so much switch. But it would be, by the end of the time that I'm done writing this game, probably millions of lines of code in this one file. And believe me, I'm capable of doing that. I don't want to do that. I would like to keep things separate, logical, so I'm going to create another instance of this target resource. And the way you do that is you right-click wherever you're going to. You actually go to new script, not new resource. Resource will be the tres file. Script, all resources start off as scripts. Up here, because we've got our class name already for this base type, we can actually just type that in right here. It will completely recognize it, substitute in the stuff, and we're going to call this composite target. Oops. Now in this case, a composite target, let's go find it. You can see it doesn't have anything here. We're going to actually copy paste this directly in. What this does now is it allows me to customize the logic for how composites interact, or how different things in here interact. I could again put if-elses or a match or whatever I wanted to do in here. I'm going to do this a little bit more logically, and we're going to do an export here. Okay, so for the first basic thing that you want regarding this particular resource, this composite target resource, is you need a list of the resources. I'm a little hesitant to put it into an array because in Godot, exported arrays are often treated differently from other data types in that they are static. But we're going to try it for this purpose, and we're going to see if it works out, because I saw some rumblings on another server that they're no longer always static. And if it works, it works. If not, it doesn't. That's what science is about. So I've got my default function here. I just create a result and return the result. This doesn't really do anything, so if we're doing TDD, this is the red part because it didn't actually do anything. To make this green, we're going to make the target resources that are passed in filter on the ones that come before it. So for example, if I have a ranged target resource and I'm using that in here, and then I have closest target resource, I'll pick all of the ranged enemies first, then I'll look for the closest one and target that one. If I were to do it in reverse, it would be a lot less likely to even find an enemy, because it will find the closest target first. This only returns one target because it's closest. That only makes sense. If I then pick ranged target, that closest target may not actually be a ranged target. And if it's not, then you won't actually get anything. Similarly, if I've got chain attack and closest, those two don't make any sense together, so I would never make that resource. Because if you're chaining on one target, it won't do anything. It'll just hit it. It'll be the exact same as a normal, closest target or what have you. So I'm not going to do that. What I'm going to do is I'm going to make these filter now. So now that we have our temporary targets like this, we're going to do something pretty interesting here. Pretty straightforward, I think. It's going to be a really, frankly, elegant piece of code. And hopefully this is going to make sense. We're going to say for target res, that's just for resource, in target resources. And since it's an array, as you can see up here, you can just loop over them like this. We're going to say temp targets equals target res. And remember, these function just like normal scripts or classes in Godot. So you have the exact same function that we're calling available on it. We're going to call self node. We're going to pass in temp targets. And we're going to pass in the mouse position again. Now the end result here is, actually, we don't even need result here, because at the end of it, we're just passing and returning temp targets. Now the only reason I did this and created a separate copy is you don't necessarily know where this is going to go in the future. This isn't a deep copy, so it's still going to affect it. I could do a duplicate and make it do a deep copy so it doesn't actually affect everything, but this is mostly just for my own sanity. Leave it like this rather than manipulating the parameters that are passed in. And yeah, that actually I think is all we have to do, because if you look now, it should filter correctly. The first time it runs, it has everything. The second time, it has only what was filtered out from this in the first place. The third time, it has only what's filtered out from both of the previous two, and so on. So a simple little piece of code there that actually should be pretty handy dandy. Now to use this, I'm going to do something kind of cool here. All I do is right click in new resource. Notice we have the name on there, composite target res, and because it's a child of target res, it shows up just fine here. And the first one I'm going to pick, actually this is the only one I'm going to pick because I only have ranged enemies in my game, so it doesn't really make sense to do something else. I'm going to do ranged closest. So notice it's just a combination of these two. And you see you have the array here. I'm going to put in ranged closest here. That's misspelled. This is just for the future when I have the target actually working. I'll add these two. Now you want to click and drag the actual tres file for it in. So I'll drag in ranged and I'll drag in closest. Now I'm doing it this way because it doesn't make sense to, because it's a filtering function, it doesn't make sense to put closest first. Closest is one target only. And if the target after that, gets filtered out is not ranged, the ranged closest will never return, or will simply not return any targets. And I feel like that's kind of not how you want to do it. I think, if a player heard the term, well, this targets ranged and closest enemies, or the closest enemy that's ranged, then if there is a ranged target that's closest, then it will find it. And so that's what this should do. Let's give it a test. We can actually give this a little test. I've got some abilities up here. You can see I actually have them as resources as well. They don't do anything. We're going to open that anyway because I removed the thing. We're going to do that too. They have targets on them. I have the packed scene here. That's used later by another piece of code. The resource doesn't actually use it. And notice I'm doing it by string. I don't drag the actual packed scene in there. You can if you want. I generally have been leaning towards just referencing it by string, and the reason for that is just it's a little bit simpler. And having the actual scene tree involved with this always feels bad. Even if it's not technically, it does feel it. So, okay, let's see here. What we're going to do now, okay, I've got my fireball attack. I'm going to give that one the ranged closest target resource. And notice I've got the tres file here. And I'm just going to pull that over here like this. This thing's a little finicky because of sizing constraints, so I'm going to pull it back. We can actually move this over. Yeah, so now we have that over here. That's going to be fine. Now, with my chain lightning attack, I just want that to be an instance of the chain target one. And I already have that. I made it down here. Chain attack. I forgot to name it. Chain attack. That doesn't really do anything right now, though, like I said. So what we're going to do is we're going to click on chain lightning attack, double click it, and then we'll go find that chain attack again. We're going to drag that over. Okay, and now the reason I put my abilities also in a folder like this is actually because I have another resource that is called, appropriately, folder list resource. And because this doesn't need the scene tree, all it's doing is looking at a folder in your game and pulling out all of the values into this all resources array. All that it does is it loads all the resources in here and then pulls them in here. And here, as you can see, I have an instance of this folder list resource, similar to how we did the other ones, which is called ability list resource. And the nice thing is I just put in the folder path. You don't have to have this category thing here. It says resource category. It's just so I can debug things later. But it points right at that abilities folder, and based on that folder that you get passed in here, it loads all of these things at once. So the nice thing is my user interface can just say, get me all those resources after it's been loaded, and then add generic buttons for all of them. And you'll see that in the world right now. You see I've got chain lightning and fireball. Those are what I named those in the thing. Now if we go with the one that's closest range, let's see if this works. Well, it's a little bit weird. It is actually targeting it, but the weirdness is I had to change some logic with this. Chain lightning actually implements the logic, so we're going to try it. You can see it's going nuts. It's because it's chaining between as many of the enemies as it can get to on the screen. Okay, and that's all. I want to say thank you to everyone who listened, and yeah, hopefully this helps you use some new ideas in your games. One thing I would like to stress is it seems like this is a lot more effort up front, because you're making these definitions. You have to think about how you want to design your system and decouple it. But because of how loosely coupled this becomes, you end up having lower coupling and higher cohesion. You end up really being able to design a clean system from the get-go. And because of that, you don't end up having a lot of problems down the line. You end up, just being able to very quickly generate stuff down the line, and you can change stuff very quickly. As you saw, like I could even give this a chain target resource. It's not really a good idea, but I could do it. And it won't actually encapsulate the logic because the resource itself doesn't move the thing. That's embedded in the packed scene itself because it has to reference the scene tree, but you could do it. All right, so I think that's about it. I'm going to wrap it up there, and hope this helps you in some way, and let me know in the comments if you are interested in more like this. Thanks. Have a good day.